Ever pondered the grandeur of our home galaxy, the Milky Way, and the mysteries it holds? Just as the human mind is a labyrinth of thoughts and emotions, so too is our galaxy a complex web of cosmic wonders and enigmas. The Milky Way, a barred spiral galaxy, is our celestial abode, a colossal cosmic structure spanning over 100,000 light-years, housing billions of stars, planets, and other astronomical phenomena. It's a vast, shimmering tapestry woven from the threads of cosmic dust, starlight, and the invisible strands of dark matter. But let's not forget, the Milky Way is but a single, albeit rather large galaxy among billions. Yes, you heard that right, billions of galaxies populate the observable universe, each with its unique structure, size, and composition. Some are dwarf galaxies holding just a few billion stars, others are massive elliptical galaxies containing trillions of stars. The universe, it seems, has a flair for diversity and scale, yet the Milky Way holds its own mysteries that keep astronomers and astrophysicists up at night. From the enigma of dark matter, invisible yet accounting for about 85% of the galaxy's mass, to the supermassive black hole lurking at its center, our galaxy is a treasure trove of cosmic puzzles. And let's not forget the numerous celestial bodies within it, each harboring potential for discovery. Stars in their myriad forms, from red giants to white dwarfs, planets with environments ranging from potentially habitable to utterly hostile, and nebulae, the ethereal nurseries where stars are born. All these elements make the Milky Way a fascinating subject of study and exploration, yet the intrigue doesn't end there. Our galaxy, like all galaxies, is not a static entity. It's dynamic, constantly changing, evolving, and interacting with its cosmic neighbors. This brings us to some of the most dramatic and cataclysmic events in our galaxy's life. Events that can reshape the very fabric of the Milky Way. Now brace yourself as we delve deeper into two of the most dramatic phenomena the Milky Way, and indeed all galaxies experience: supernova explosions and galactic collisions. Imagine a stellar explosion so powerful that it outshines the entire galaxy. This isn't sci-fi, it's a supernova. A supernova, in its most basic sense, is a stellar explosion. But in the vast expanse of the cosmos, it's far more than just that. It's a celestial spectacle of energy and light, a cosmic cataclysm that's as awe-inspiring as it is essential to the very fabric of the universe. So, how does such a monumental event occur? It all begins with a change in the core of a star. When a star exhausts its nuclear fuel, it can no longer sustain the balance of forces within its core. As gravity takes over, the core collapses under its own weight, triggering a shock wave that catapults the outer layers of the star into space. The result? A supernova. But not all supernovae are created equal. There are two main types, each with their own unique origin story. Firstly, we have Type 1 supernovae. These occur in binary star systems where two stars are locked in a cosmic dance of gravity. Over time, one star can start siphoning off matter from its companion. Eventually, this star becomes so dense that it triggers a thermonuclear explosion, resulting in a Type 1 supernova. Then there's Type 2 supernovae. These originate from a single massive star. When these solitary giants exhaust their nuclear fuel, their core collapses under its own immense gravity. This collapse triggers a shock wave that rips the star apart, causing a Type 2 supernova. These stellar explosions are not just cosmic fireworks, they're also cosmic factories. They forge and distribute elements across the universe, elements that are essential for the creation of planets and even life itself. From the iron in our blood to the calcium in our bones, these elements are stardust, remnants of ancient supernovae that have journeyed across the cosmos to become a part of us. These stellar explosions are not only spectacular to imagine, but they also play a crucial role in the universe, seeding it with the elements necessary for life as we know it. Now imagine two galaxies, each with billions of stars, locked in a cosmic dance that ends in a dramatic collision. Sounds catastrophic, doesn't it? But let's take a step back for a moment. What exactly is a galactic collision? Well, quite simply put, it's when two galaxies under the gravitational pull of each other come together and merge. This process isn't a quick one, though. We're talking about a dance that spans millions of years. Now, you might be picturing a chaotic, destructive event with stars smashing into each other and causing all sorts of interstellar mayhem. But the reality is surprisingly different. The vast distances between stars mean that direct collisions are incredibly rare. Instead, the galaxies slowly meld together, their stars sliding past each other like ships in the cosmic night. But what happens to these galaxies during this process? Well, as they draw closer, the gravitational forces at play start to distort their shapes. Spiral galaxies, like our own Milky Way, can be stretched out into long tidal tails, creating a spectacle that's truly a sight to behold, if we could speed up time, that is. The real action, though, is in the gas clouds. These enormous collections of hydrogen and dust are where stars are born, and when galaxies collide, these clouds can be compressed, triggering a flurry of star formation. This is why galactic collisions often lead to a burst of new stars, lighting up the merging galaxies like a cosmic fireworks display. But it's not all about creation. These events can also lead to destruction. The intense gravitational forces can fling stars out of the galaxies entirely, sending them off into the vast emptiness of intergalactic space. And in the centers of the colliding galaxies, supermassive black holes can merge, releasing powerful jets of energy that can blow away gas and dust, shutting down star formation. So, what's the end result of all this? Well, after all the drama, all the creation and destruction, the two galaxies eventually become one. They settle down into a new, larger galaxy, often with a different shape to the galaxies that came before. The stars, gas, and dust from the original galaxies are mixed together, creating new patterns and structures. This process, as chaotic and violent as it may seem, is a fundamental part of how galaxies evolve. Our own Milky Way has likely been through several of these collisions in its past, and it's currently on a collision course with the Andromeda Galaxy. But don't worry, this won't happen for another 4 billion years or so. While it may seem like a chaotic event, galactic collisions are in fact an integral part of the evolution of the universe, leading to the creation of new, larger galaxies. In the vastness of our Milky Way and beyond, supernova explosions and galactic collisions are common occurrences, painting a picture of a dynamic, ever-changing universe. The tale of our cosmos is one of birth and destruction, with supernova explosions and galactic collisions playing central roles. In the earlier scenes, we explored these phenomena, unraveling the mysteries of the universe in the process. Supernovae, those brilliant, destructive bursts of energy, are significant players in the cosmic theater. These dazzling explosions mark the end of a star's life, but they also herald the beginnings of new celestial bodies. The dying stars explode with such intensity that they seed the cosmos with elements, the building blocks of life. It's a fascinating paradox. Destruction giving rise to creation. These explosions scatter elements like carbon, nitrogen, and oxygen across the cosmos. These are the very elements that make up our bodies, the earth beneath our feet, and the air we breathe. So in a sense, we are all the products of ancient supernovae, stardust looking up at the stars. But the drama doesn't end there. We also explored the dance of galaxies, those grand collisions that shape the universe. When galaxies collide, they don't just crash and burn, they merge, evolve, and form new galactic structures. It's a dance that takes billions of years, a testament to the slow, persistent march of cosmic evolution. These galactic collisions are not just spectacular events to observe, they hold the key to understanding how our universe grows and changes. They show us that the cosmos is not a static, unchanging expanse, but a dynamic, evolving entity. In essence, supernova explosions and galactic collisions are the universe's way of maintaining a cosmic balance. They are the mechanisms through which the cosmos renews itself, a cycle of creation and destruction, birth and death that has been in motion since the dawn of time. The next time you gaze up at the night sky, remember the cosmic drama unfolding in our galaxy and beyond, as stars explode in brilliant supernovae and galaxies dance towards inevitable collisions. This is the mayhem and the beauty of our universe.